I'm Anil Kumar. Welcome to my series on quadratic functions. We have 4 examples here and we'll discuss completing the squares and its applications. So first we'll try to understand few concepts of completing the squares and then take up question number 1, which is express each of the following in the form of x minus h whole square plus k. And we have 4 different functions here, all are quadratic. The leading coefficient here is 1, right? So you see x square, x square, x square, x square terms. Question number 2, the leading coefficient now is not 1. And the question here is, express f of x equals to 2x square minus 8x plus 5 in the form of a x minus b whole square plus c. Find the coordinates of stationary points of f of x, write range of f of x. Now, stationary point is the turning point, and completing the squares is very essential to understand how to get the turning point once we have quadratic equation standard form. Range also you can calculate easily, since we know if the leading coefficient is positive, parabola opens upwards, so from the turning point the y value range will be greater than, but if it is negative then be less than, equal to that point, right? Value correct. Question number 3 here is, express f of t equals to minus 5t square plus 20t plus 26 in the form of a t minus b whole square plus c, where when is f of t equals to 0 for t greater than or equal to 0. So that's a very good application which you find in throwing a ball, for example, and you need to figure out when did the ball land on the ground, or what was the highest point reached by the ball, right? So that refers to the function where time is your independent variable. Question number 4 here is, find inverse of the function x squared plus 4x minus 5. Now directly you cannot find inverse of a quadratic function if given in standard form. You need to complete the squares and then get your answer, right? So kind of in this form you have to write your equation and then you get your answer. So the basic concept about completing the squares is to understand the equation. If I have, let's say, x plus let's say d, right? So whole square, then that is a perfect square, right? If you expand this, you get what? You get x squared plus 2 times x into d, but we normally write d will be treated as a constant, right? So we write 2 times d times x plus d square, right? So that is the expansion. So the idea here is that if you're given like this, x squared plus 10x, right? So 10 is 2 times d. Do you see that? 10 is 2 times d. So in one method what we do is we do half of this and add and subtract its square, making the 3 terms a perfect square, right? So you get an idea, right? So that is the whole idea. The other way to look into it is that if I am given something like this, that is to say, if I have given x squared plus 2 dx, then I could write this as in a form which is called the vertex form, as we can take this d square to the left side, right? So we get x plus d whole square minus d square. You get this idea. So directly also, if I have x squared plus 2x, now you can see I could complete the square and write this in x plus d whole square minus d square, right? So this could be written as, so what is d? The coefficient of x, half of that is d. Do you see that part, right? So half of 10 is 5, and therefore I could write this as x plus 5 whole square minus d square, which is this number 5, so minus 25. Does it make sense to you? So it becomes so simple as that once you understand the concept. Correct? So we'll actually apply this concept and also the other one. And this completing the squares method is very good if we are using coefficients which are not 1, right? So let's see how to use these concepts to find vertex form, right? So when we complete the square, we get vertex form of quadratic equation. Right, so we say y equals to a times, in this case we are saying, for example, x minus h whole square plus k. Is it okay? So that is the vertex form of our quadratic equation. Okay. So let's take up the very first example. So I did one of the examples earlier. Again, let me repeat the concept here. So what we said was that, let me write down here. We said that if I have something like x plus d whole square, I could write this as x square plus 2dx plus d square. So I could convert x square plus 10x, which is kind of like this, as x plus d whole square minus d square, right? So what is d here? D is half of the coefficient of the term x. You get the idea, right? So that is the case. So let's do it. We'll apply this strategy for solving both of them. So d for us is 10 divided by 2, which is 5, right? So I'm writing this expression, so we can write f of x now as equal to x plus 5 whole square minus d square, means minus 25. Is that clear to you, right? So if this is positive, we take positive term, right? Now, think about it like this. If instead of positive, we have negative, that is to say, if I'm writing x minus d whole square, I get x square minus 2dx plus d square. So in this case, we get x minus d square minus d square equals to x square minus 2dx. Similar situation, but that sign is negative. So in this second example, we could write g of x as equal to x minus half of 6, right? We have to divide 6 by 2. It gives us 3. That is the value of d which we are talking about, correct? So it is 3 which we are going to put here, perfect square, and then this is always minus. Do you see that part? When you take it on this side, whether you use negative or positive, it is always minus. So it is minus square of 3, which is 9. Is that clear to you? So that is our answer. So in one step, without doing much, you can get your solution, provided you understand this concept, right? So now let's take up the other two examples, and we'll follow a different method in those. So we could adopt the method which we just did to solve these. So we say method 1. Let me do it with two methods now. So method 1 will be h of x equals to half of 12 is 6. So we could write this as x plus 6 whole square, right, minus 6 square, right? So 6 square is 36 plus 1. So what we did was we wrote this portion here as that, correct? And now I'm just combining the two like terms and writing this as x plus 6 whole square minus 35. Do you see that part? So we have done it within a step, one step solution. Is it okay? Now here is the alternate method, which is a very popular method normally used. Let's see how do we do it normally, right? So we will again begin with our function h of x equals to x squared plus 12x plus 1. So in completing the squares, what we do here is we take these terms with x, right? Half of 12 is 6. So we add 6 squared and we subtract 6 squared. We keep that one aside. So these three terms form a perfect square, x plus 6 whole square. And we have minus 6 squared, which is minus 36 plus 1. and then you could write this as x plus 6 whole square minus 35. Is that clear to you? So that is the alternate method. Perfect. So both methods are good enough. You could adopt any one of them. Let's do the next one, right? So we'll do with both the methods. So we could write this as p of x equals to, whenever it is an even number, this method is perfect. We can write this as x minus, because this is minus 4 half of 8 whole square, and then minus 4 square. Let me write 4 square this time, plus 4, right? So we get this as x minus 4 whole square, and that is 16. Minus 16 plus 4 is minus 12, correct? So we get our answer p of x as equal to that, right? Now let's do the second method, which we are saying the alternate method. Perfect. Now the alternate method is that we're given the function x squared minus 8x plus 4. We will actually, in this case coefficient is 1, so we'll directly write half of 8 is 4, so we'll add 4 square, subtract 4 square, we have plus 4 already there. Now these three terms form a perfect square, x minus 4 whole square, and we are left with minus 4 square, which is 16 plus 4. And now we could write this as x minus 4 whole square minus 12. Is that clear to you? So exactly same answer you're getting. Perfect. So I hope now you've understood the process. Let's take up the next question. Now in this case, the coefficient is not 1, right? So we'll have to factor this out and you'll see how we should do it. Question number 2 is, express f of x equals to 2x squared minus 8x plus 5 in the form of a times x minus b squared plus c. Find the coordinates of stationary point of f of x, write the range of f of x. I'd like you to pause the video now, answer this question, and then look into my suggestions. Now in this case, f of x is 2x squared minus 8x plus 5. So it is a parabola which opens upwards, right? So it's a parabola which opens upwards. When we are saying find the coordinates of stationary point, that is called the stationary point, the turning point, right? And the range is above this and equal to this, right? So that is the concept. But how do we find the vertex? So we have to write this equation in the vertex form. So completing the square helps us to write in vertex form. So we have to write vertex form of quadratic equation. Advantage is you can read the vertex directly. We are given the equation f of x equals to 2x squared minus 8x plus 5. So how do we write the vertex form? The process is completing the squares, correct? So we need to complete squares. So you see it's a huge application, right? Now, previous examples we had coefficient of 1, now we have a different coefficient. So we need to factor this out. So factor 2, the coefficient of x squared from the first two terms. We get x squared minus 4x. So only do it with the terms having x, keep the constant away. That is your first step, right? So first step here is to factor the leading coefficient. So factor leading coefficient. Correct? Now, we'll follow the steps which we did earlier, which is we have x squared minus 4x. So leading coefficient now is 1. We'll look into half of 4, which is 2. So we'll add and subtract square of 2. Perfect. We'll keep this 5 like this. So the next step here is to add and subtract half of coefficient of x. Is that clear? Square. Half of coefficient of x square. Right? So half it and then square it. That's what we mean. Okay. So now we get these three terms as a perfect square. So I could write this as x minus 2 whole square. And this minus 2 square is minus 4, right? Now we need to open the bracket, multiply by 2. You get x minus 2 whole square. And 2 times minus 4 is minus 8 plus 5. Do you see that? And now we can finally write our answer in the vertex form, which is 2 times x minus 2 whole square minus 8 plus 5 is minus 3. Is that clear to you? So we get the vertex form of the parabola. Correct? So this quadratic equation represents the parabola. Now from here, find the coordinates of stationary point. Let's say this is part A, right? So the part A should be expressed, and now this B and this C. So we did part A to write this in the vertex form. And now let's do part B, which is find the coordinates of stationary point. Now the coordinates of stationary point are, you can directly read from the vertex form, which is, let's call this as V, the vertex. So the stationary point is 2 minus 3. So that is our stationary point. Or the turning point. Is it okay? Okay, now part C. What is the range of this? So the range is, as it opens upwards, the range is the y value, or f of x, belongs to all real numbers where y is greater than or equal to the minimum, which is minus 3. So that is our absolute minimum, right? So the vertex in this case shows you absolute minimum. Therefore the range will be that the y value is greater than or equal to minus 3. So I hope that is absolutely clear, right? So we have learned both the methods, that is how to complete the squares when the coefficient of x squared or the leading coefficient is 1 or it is not 1. Now with that in mind, let's move forward and do the next two questions, right? Question number 3. Express f of t equals minus 5t squared plus 20t plus 26 in the form of a times t minus b whole square plus c. When is, now the question for you is, there are two parts to it again, right? When is f of t equals to 0? For t greater than or equal to 0. Perfect. So let's do part A first, which is writing in vertex form, right? So we are given the function of time as minus 5t squared plus 20t plus 26. You can always pause the video and solve and then look into my suggestions. First step, factor out the leading coefficient. So we factored minus 5 t squared, divide 20 by minus 5, you get minus 4t, right? Plus 26. Now next step, we have to do square of half of coefficient of t, right? So half of 4 is 2. So we'll add and subtract 2 squared. So I've taken very simple, useful examples to understand the whole concept. T minus 4t plus 2 square can be written as t minus 2 whole square, right? Minus 2 square is minus 4 plus 26. Now we'll open this bracket and we can write this as minus 5 times t minus 2 whole square. Minus and minus makes it plus 20 and we have plus 26. So we get minus 5 t minus 2 whole square plus 46. Perfect. So the vertex in this case is what? Vertex in this case is 246, and as you can see the leading coefficient is negative. So in this particular case we have a parabola which will open downwards. Is that clear? So we have absolute maximum at this vertex. Perfect. So we've done the first part, which is expressing this in the form of a t minus b whole square plus c. So from the comparison, you can write that a is equal to minus 5, b is equal to 2, and c is equal to 46. Is that clear to you, right? If you compare with what was required. Now let's look into part B, which is when is f of t equals to 0, right? So let's figure this out. So we'll just write 0 equals to whatever we got, which is minus 5 t minus 2 whole square plus 46, right? So we can bring 46 to the left side, because minus 46 equals to minus 5 t minus 2 whole square. Now divide by minus 5. So minus 46 divided by minus 5 equals to t minus 2 whole square, right? So which will be, so let's, we can do it later, we can do it now also, right? So let's do, we have 46 divided by 5, which is equal to, in, you can write in decimals, 9.2, right? So 9.2 is t minus 2 whole square. Now when you square root, you get plus and minus. We'll do square root with plus and minus. 9.2 equals to t minus 2. Clear? So t will be what? Bring 2 to this side. So you get 2 plus minus square root 9.2 for t, right? Now what we are also given here is that t is greater than 0, right? So if t is greater than 0, we are not looking into minus side. So we say t is equals to 2 plus square root of 9.2, correct? So let's figure this out. So we have 2 plus square root of 9.2, which is equal to, in decimals, 5.03, or you can say approximately 5, correct? So the value of t is 5. What it really means is something like this. Let us say we just have a, let me just sketch something like this here. Okay. So with the minus will mean that, you know, it is kind of like this, right? So we are looking at this point. So from 0, this point is approximately 5 units away, correct? Correct? And this point here, which is the y-intercept, will be 26, right? And this point, which is the maximum, is 46. This point is at 246. Do you see how with the help of this equation we can correlate all the things, right? So that is what we get, and we say, well, here t is equal to 5. So when is f of t equals to 0? When t is 5, right? So in case of example where a ball is thrown, it is going to hit the ground when t is 5, correct? Okay. So that is how we'll solve this question. Now this could be in your test in a different way. Example could be throwing a ball, and you may be required to find domain and range, right? So if you're throwing a ball, it will stop here, right? So the range will be from 0 to 46, right? And domain will be from 0 to 5. So I hope that makes sense, correct? Let's move on and take the last question now. Question number 4. Find inverse of f of x equals to x squared plus 4x minus 5. So we could write this as y equals to x squared plus 4x minus 5. To find inverse, we have to swap, right? So you need to swap to find inverse. Directly, you cannot find inverse from a quadratic standard form of an equation. So you need to write this into a vertex form. So we'll have to swap to find the inverse. And why? Well, let me do it first. So we write x here, and we got y squared plus 4y minus 5. And now the next step is to isolate y. Now here we have two terms with y. You cannot isolate directly. So to isolate, we have to complete squares. Do you see its significance, right? So completing the squares is a very useful method. You need to master this. Okay, so let's complete the square. So we have x equals to y squared plus 4y. Half of 4 is 2. So we'll write plus 2 squared minus 2 squared minus 5. So now we can write this as y plus 2 whole square minus 2 squared is 4 minus 5. Correct? So that gives us y plus 2 whole square minus 9. Right? Now you can isolate, right? So bringing 9 to the right side, we get x plus 9 equals to y plus 2 whole square, correct? Now we'll square root it. So whenever you square root, you have to write, let me write x first, right? Plus and minus, we get y plus 2. Now you can isolate y, and you get y as equal to minus 2 plus minus square root x plus 9. Is that clear to you? Perfect. Let me rewrite this on the right side. So what we did here was we did square root. So whenever you do square root, you have to do plus and minus. So we get y equals to minus 2 plus and minus square root of x plus 9. Is that clear to you? Right? So we can write f inverse as equal to minus 2 plus minus square root of x plus 9. Now since for every value of x in the domain of x, we will get two values. It is not a function, right? So note, inverse of f of x is not a function. Is that clear to you, right? So it makes sense because this is a parabola, right? So this is a parabola which opens upwards and it fails the horizontal line test, right? So the inverse is basically like this, and plus and minus makes it kind of like this. Do you see that part, right? So it is not a function. So that should be very clear. Well, in this exercise, we learn a couple of things. Let me summarize. So we learned the method of completing squares. And it finds huge applications, and one of these applications is to find domain and range, to find stationary point, and also to find inverse of a function. Is that clear, right? And when we say domain and range, we mean absolute, maximum or minimum value, right? So that means the whole lot of optimization questions optimization examples will be solved using the method of completing the square. So it is extremely important. So I hope you understand significance also. So I'll recommend you to master this technique. You can see some of my videos based on this. And if you like this video, that's great. Feel free to write your comment, share my videos with your friends, and if you subscribe, that'll be great. Thanks for watching and all the best.